Okay, folks, so let's start because I need to complete the presentation today. Okay, so today we'll study these parts. We'll see what is the basic design principle of Bitcoin and the blockchain. Okay, and we'll focus mainly on the concepts. Okay, details, of course, you can find from the excellent books written by authors. All right, so let's start with the basic design principle. Okay, please feel free to ask me questions because it's not easy to understand the concept, but we'll just restrict ourselves to the main principles, right? Okay. First thing is identity management. How do you identify a user, right? I mean, you open account in a bank, then they prove your identity. For example, your name, then they will ask you to give you a proof that you are you. Then you produce, give to them, either passport copy or maybe your one of the identity, driving license or even Aadhaar card number. If you don't have it, you ask institute to write a letter to them and so on. Okay, so there is a need for identity management, right? So in any system, for example, even in email system, there is a user email ID that is associated with your name, or any other thing. For example, you open an account in amazon.com to buy something, then even then they ask for uh, some proof, right, of your identity. So you create your identity, give your email address, and you can give your name and so on, right? So similarly, in internet work, the identity of a machine is IP address. Okay, so without identity, transactions cannot happen, right? So in Bitcoin, the designer Satoshi has thought that what should be identity, and now he wanted that every user should be anonymous. Okay, now the 100% anonymity is not possible in Bitcoin, so that's the reason we call it pseudo anonymous. Okay, so instead of using name and so on, then there's a public key and private keys are used. Okay, uh, so public key and private keys are used as an identity. So public key, of course, is given to a public to send you money, or anybody can use your public key, for example, to make a transaction with you, okay, or give you some money. Okay, and private key is something that you will use to unlock that. Somebody has sent you some money with then the message is encrypted with your public key, then you can decrypt it and do the transaction, complete the transaction, receive the money, right? This so identity is primarily with these two. Okay, so now public key, of course, is available to all. You can publish it or you can send it to somebody. Okay, so you understand right now how do we create public key and private key? We have done asymmetric key encryption algorithms, right? And then in general, private key is chosen first at a random, and from that public key is derived. Okay, note that there is a relationship between private key and public key depending on what algorithm you are using. It's not two randomly independent generated key, right? So please keep this in mind. Okay, all right. So public key is for okay. Public key is for receiving. It means that Alice and Bob is there. So Bob will use Alice's public key of Alice, and then Alice will use private key or secret key to decrypt it. Okay, all right. So note that these two keys are used, and so like my name is Ravi Mittal, so and that's my identity, right? And then maybe if there are hundreds of Ravi Mittal, then I may use son of my father's name. And if my father's name is also very common, then could be I can use, my city and whatever, right? So here users are known by their public key. Now, who will create this public key? Now note that public key and private key are connected, right? If third party creates it, then we'll also know the private key. Okay, so it means that public key and secondly, it's actually user's responsibility to create public key and private key. It means that you are going to create your own public key and private key and so on, right? Okay, so no personal information is required, no limit on how many accounts you can create. As a person, you may want to create thousands of Bitcoin account, you can do that. It means that if you want to create thousands of public key and private key pairs, you can do that. Okay. So no restriction on keys, and keys are generated by user. So what is the probability that I have generated my public key, private key, and you have also generated that independently? Both can be same. It means that somebody is sending money to me based on my public key address. Now it may go to you. That's possibility, right? Then why Bitcoin is allowing that? We'll come to that answer, right? Okay. All right. So anonymity we have seen. So Bitcoins are associated with keys. Okay. So Bitcoin uses identity, which is mainly public key address. Public key is called also address. Okay. So in Bitcoin, secret key or private key is 256 bits and public key is also 250 bits. Now note that this is very large, right? Big number. How do you remember it? This is another question, right? That we need to solve. We will not solve in this class, but there are ways to codify it, right? Public key of 250 bits is just too large. You want to send money to Bob and Bob's key is 256 bits, just too big, right? So there is a way to compress it. Okay, so we will come to that later. So Bitcoin users, so of course anybody can participate in Bitcoin network. That's another beauty of Bitcoin network, that it will not say you cannot do it because you are a child. Okay, you don't have 21 years of age, so you can't do it. I mean, a newborn baby can do it. All right. So of course this is a public key of Bob, and this is a secret key of secret key of Alice. This is public key of Bob and secret key of Alice. Okay, so we use terminology PK and SK. We don't use private key here. In general, in crypto discussion, we call it secret key. Okay, so now these keys are very long. Okay, private key has to remain same, but public key can be compressed because 256 bits is just too large, right? So we can hash it and then convert it into 160 bit key. There's a minimum that's required, right? Okay, so it can be this can be used. Now we are not, in rest of our discussion, we are not going to consider short form of public key address, right? We will consider that both private key or secret key and public key are of same size, which is 256 bits. Okay. Now the question that I'm asking is that let's for now consider that public key size of 160, not 256. So, and what is the probability considering that your public key is 160 bits and my public key is 160 bits, and we are choosing all these randomly? What is the probability your and mine key is the same? Okay, it's like you go to Goa beach, okay, one of the beaches, and take a grain of sand and color it and drop it there. And then your next friend goes after some time and picks up one randomly, one grain. What is the probability that he will get the same grain which you have colored? Okay, so probability of two people picking the same public key is even lower than that. Okay, an example is given here that grains of sand on earth is 2 raised power 63, and assume 2 raised power 63 such earths, right? And then probability of finding the same grain is, is very, very small. It's just, this very, very small, even of 2 raised power 160, not even 2 raised power 256. Okay, so basically, although you are generating keys and random, the probability of two people having the same key is very, very small. If it happens, it's your bad luck then, or that person's bad luck, I mean, who also has a same key. All right, any question? All right, let's move on, right? So okay, there's one thing that we have seen, and of course identity problem we have solved, that we can have public key, private key, and that's our identity. The problem with digital currency is double spending. Like, your paper note or paper currency, you cannot spend the money twice. Even if you have given the note to vegetable shopkeeper, then that's gone. You don't have that note available with you, right? Because you cannot copy it. Copying paper note is extremely difficult, extremely hard. It's not possible. Okay, but beauty of digital technology is that you can copy anything in a second, less than a second. Okay, you can make hundreds of copies of digital currency or Bitcoin and send it to many people. So we need to solve this problem that money has a value, and that value you cannot send it to multiple people, right? Okay, so double spending has to be, because this user can create multiple copies of the currency and send it same currency to multiple users. This should not be allowed. Okay, all right, that's first challenge. Second challenge is no stealing. Alice has a money, say for example 100 Bitcoin, okay, and she has right to send it to anybody. Okay, but Trudy or Mallory don't have right to send Alice's money to somebody else. So Mallory is here and she sends this money with whatever identity the money has to somebody else. This should not be allowed. Okay, so it's my money, only I should be able to send it. It's not somebody else. Okay, so the stealing should not be possible. Okay, third is that how there should be a way to generate money. Okay, or fair money creation. Right? So even in our systems, for example, when yesterday government has a rate increase the, some because of inflation, the rates have changed. Okay, so government can do that, right? Government can create money. Government can increase the number of notes in circulation. Okay, so there must be a way here also to generate money or mine money, which we'll say. It's called mining or minting. Okay, so there should be a way. So no stealing is solved with cryptographic signatures. Okay, it means that nobody should be able to steal my money if I sign the transaction that I am doing. So every transaction, when I'm sending money to somebody, it should be signed by my digital signature. That's a simple solution, right? Double spending is that you keep it in open. Everyone should see the transaction, and everyone should see all the transactions that has happened. Okay, then everyone can see that I am double spending it. Suppose I'm sending money to you and your friend, and this transaction that I'm making between me and you goes to a public ledger, and then money I'm sending it to somebody else also goes to public ledger, then anybody can see that there is a fraud happening, because they all, then they can also see where did I receive the money. And they all know that I have 10 bitcoins and I am sending 9 bitcoins to you and 5 bitcoins to somebody else, and all these transactions that I am making are going to a public ledger which is visible to all, and everyone has a copy of that ledger, right? Then they can always see that I cannot spend more than that I have. Okay, so double spending is solved by having a public ledger which we call as a blockchain. Okay, and then minting a fair amount of fair money creation, or minting money is through creating a proof of work. So all these people who help running this system, which will come later, are paid some incentive or given some incentive in terms of bitcoins. Okay, now the question is that all these are the question: who runs public key infrastructure, who maintains public ledger, who gives money to puzzlers, right? And can this be decentralized? Okay, we'll try to answer these questions, right? Okay, now of course there has got to be a set of people who are the key programmers or developers or key proposers and so on and so forth, right? And they propose whatever, and it's available to everyone, and based on that it runs. All right, so we'll look at that later. You can also read it from the book, some of these questions. I just want to have plant this question in your mind so that you start thinking about it. Now, so when Alice sends money to Bob, she has to create a transaction. She cannot just send an email that I'm sending money to you. There is a proper format defined in which she has to send it. Okay, and that is called transaction. Okay, so now transaction should contain, of course, transaction properties are authentication, signature, integrity, and there should be enough available funds, and no other transaction use the same fund. So these are the requirements. Okay, now let's come to the actual one, right? So Bitcoin transactions are based on digital signatures. When Alice sending a money to Bob, she is creating a transaction, and then she is signing the transaction with her secret key or private key. Okay, now because she is signing this and everyone knows her public key, then they will come to know that it is actually coming from Alice, nobody else, right? Okay, so now it will have, transaction will have Alice's ID, which is nothing but her public key, and Bob's ID, right, which is a Bob's public key. Okay, and the amount she is sending, an amount, how many bitcoins she is sending. Okay, and apart from that, the transaction will also have hash pointer, and these hash pointers will tell where Alice has got the money. So it's basically it will reference to some blocks in the blockchain which will tell the Alice has got money from somewhere. Okay, so H is hash links to earlier transactions, because now everyone can see that where Alice has got money, bitcoins, and then she is not double spending. Okay, any question? Any doubt? Okay, let's go ahead. So now a transaction is also called moving coins, or move coins from one place to other. So Alice wants to send some bitcoins to Bob, she creates a transaction, send it to one or more Bitcoin nodes. She just creates. Now the whole process is that here we have shown for simplicity that she is sending it to Bob. Actually, this transaction is reaching Bob in some way, not necessarily that she is sending it directly, right? Okay, so she creates a transaction, send it to one of more Bitcoin nodes. She may just send it to one Bitcoin nodes, and that Bitcoin node, which is usually a miner, okay, who mines the money or who is a part of the system, okay, that node tells all its peers about the transaction. Okay, and within 5 seconds, every peer in the network has it. Every node in that network of miners or those people, right, who are associated with Bitcoin has it. And you can also be, of course, miner. Okay, now so it means that every miner will continuously listen about the transaction, and they keep collecting those transactions. Okay, transaction records, but the transaction which Alice has done is still not confirmed. It's not confirmed yet. So every miner says start creating a block, putting all this transaction coming from different places. Okay, now what this transaction contains, now this is a transaction in a block. The transaction contains inputs. Okay, okay, so inputs is like h here, hash pointer we have seen here. Okay, where does Alice got the money? So it points to it. So those pointers are there. Okay, pointers to the blocks, and the blocks can be checked, right? Because a block has only limited number of transactions. Okay, all right, and then the output of that, because transaction has got to go to somebody. For example, Bob's public ID and the amount. Okay, all right, and apart from that, there is something very interesting which is called change. So whatever money, say for example, Alice has 2 Bitcoin. Okay, associated with a public key and private key. Of course, public key to outside world, and she sends only 1 Bitcoin to Bob. Okay, so now 1 Bitcoin will left with Alice. Now that is not allowed. Her account should show 0. Okay, that's interesting point, right? So now what will she do? She will create another transaction and show that Bitcoin is coming to her back. Okay, so it's a so basically how it is done, actually you can see the details in the book. So but interestingly, every input is basically where she has received money at time t, whatever money she has. Okay, she has, although she is doing partial transaction to somebody else, but she has to complete, so she is sending only part of that money that she has, but she has to completely spend it. Okay, now what could be logic behind it? Just think, it's very obvious. Okay, of course it will reduce somebody's search time later, because you are creating otherwise one has to go to 500 blocks back to see Alice has got money from somewhere and so on. Okay, okay, all right, so when a Bitcoin node, it means that it is a miner or the participant in the whole process, receives a transaction and performs several checks. So Alice has created this transaction, okay, and is received by many people. Okay, many people have received it. Okay, what will they do? They have to do something, right? They just can't put this in kind of block they are trying to create. They are still trying to create, right? So they will look at this, but they will have to validate the data is correct. First thing is this Alice's signature is there, right? So they will check. They will use Alice's public key and then decrypt it, right? So it means the signature matches is fine. Okay, signature matches is fine. Then it means that whatever is there, which is in plain text, is correct. Okay. Note that signature by having a signature doesn't mean we are encrypting the message. We are just signature is beside the message or the transaction, right? Okay, the content of the transaction, main content of the transaction, because signature is also part of the transaction. Okay, all right. The transaction, and then whatever is the data inside, where she has received money, etc., etc. All these checks are done. Okay, and also seen whether she is not double spending, right? So all these people will do, or nodes will do this activity. All right. Okay. So what we are trying to have is that we are trying to have a trusted bulletin board in a distributed way. Okay. Right. So so that is called blockchain. So every node will have a copy of the blockchain. Okay, which is a number of the blocks one after other, and these miners are trying to create these blocks. Of course, transaction is in this form that we have seen, and this concept we have already seen. So now we come to the concept of blockchain. Each node keeps a complete copy of entire ledger. Right from beginning, Satoshi has created. If you want to see, you can see each and every transaction that has happened so far. It means that it will have a large number of blocks, and each block will have certain number of transactions. Okay, currently ledger is more than 400 GB. This of course is almost like 2 years old data. Transactions are grouped into the blocks. Of course, we know that transactions are grouped into blocks, and there are multiple blocks, and starting from the first block that was created by Satoshi and so on, it's keep on increasing, right? And each block contains approximately 2220 transactions, and each transaction are 250 bytes. So block size is approximately 1.25 MB. And in the world, every 10 minutes a new block is added. Okay, so now from the time we started the class, almost like 3 blocks would have added. Okay, now this shows a block created in approximately 10 minutes. Okay, so all right. Okay, so now checks and balances are continuously done, and these miners can do that, and you, even if you want, you can do that, because all this blockchain is available in plain text. You can see a particular public key or identity, where the person, where that identity has got money and where it's spent. Anybody can see that. Okay, for example, in this example, like this is these are a set of transaction in a block. Okay, starting at time t. So time t to time t plus 1, which is approximately 10 minutes. These records are accumulated by each miner. Okay, and then this block has to be approved by everyone, so which will come to later, right? But let's see, look at the first transaction. There is Alice sends 1 Bitcoin to Bob, Alice sends 0.7 Bitcoin to Chris, Bob sends 1.2 Bitcoins to Dave, and Dave sends 0.2 to Chris, and so on. And so at time t, Alice has 1 Bitcoin and Bob has 5 Bitcoins in the beginning, and after t plus 1, Alice will have 0.3 Bitcoin and Bob will have 0.48 Bitcoin. So all these checks balances are done. Okay, so everyone can see that. All right. And then required properties of blockchain is that blocks can only be attached. So this already existing blockchain consists of certain number of blocks, and every 10 minutes or so, one new block is attached. You cannot remove a block. Okay, now because it has is visible to everyone, and all transactions that are part of that have been checked that they are correct. And this blockchain is distributed, means anybody, and of course not, I cannot do it because I'm not part of that group, but kind of all miners who mine the money and maybe few other people can, they can have this blockchain. Okay, you can also download the blockchain and see it, but you don't have rights to participate in the whole process because you're not part of that group. Okay, so it means the blockchain is not kept in a central place, it's kept in any machine which is part of that whole network, and anybody can be part of that network. Okay, this concept is shown here. So basically miners are a special type of users. Okay, they keep copy of blockchain. Okay, and blockchain keeps on increasing as time progresses. Any question? I'm sure you will have some question by now. Wow. Okay, all right, let's move ahead. Now question is that every user has, every miner has, will listen to all the transactions that are coming from Alice, Bob and whoever, and tries to create a block. Okay, now if every users can create it, then the blockchain will not look same. It means that only one, although all of them are trying, but only one of them should be able to increase the length of blockchain. Okay, and that's, here comes a concept of proof of work. Okay, now before announcing that I have created the block, they have to do some work. Okay, all right. Okay, and okay, and then people will check whether it is correct or not. Okay, all right. Now here comes a concept of distributed computing, that these miners will vote whether the block that is going to be created is correct or not. Okay, now this whole mechanism will work if majority are honest. If majority are not honest, this will not work, right? Now here that's, and there is an incentive for people to be honest in the whole mechanism, right? So at least more than 50% have to be honest for things to work. All right. So if there are two guys out of five, two guys are attackers, then still it can work. Okay, because there is a concept of voting. All right. So they, once a new block, a user creates a new block, for example this block, and sends it to everyone. Okay, after doing proof of work, which will come later, then everyone votes and say is correct or not. Fine, same concept which we discussed earlier. Now there is a challenge here. Now what, so for example, I can create multiple identities of myself. Okay, because nobody can stop me, right? I can create 100 entities of myself and then participate in voting. Okay, so this is called Sybil's attack. Okay, multiple identities belonging to the same malicious user. So basically multiple copies of oneself. This is a small number of entities counterfeiting multiple peer entities, so as to compromise a disproportionate share of system. So if all these guys participate in voting, then these guys win, right? So they can now attach a malicious block or with wrong transactions. Okay, now that simple solution of that is that it should be based on the computational power, not on the identities, right? So now all these entities are part of one computational power, so it shouldn't matter then, because this will be treated as one. So Cybele creation does not increase the attacker's computational power. Okay. Now, in order to implement that, the system is designed in such a way that before any miner can announce that he or she has created a block, a puzzle is to be solved. Okay, that's called proof of work. Okay, in order to measure a user's computational power, I ask him to solve a puzzle, and this puzzle should be difficult to solve, but solution should be easily verifiable. Now, puzzles in Bitcoin are based on cryptographic hash function. Okay, now comes the concept of course, we'll come to proof of work later, but we'll see that how block creation happens in very brief. Each miner has a copy of blockchain that we have seen. Okay, and every block, one block is added every 10 minutes that we have seen. The first block, of course, which is block 0, is created by Satoshi in 2009, and then subsequent blocks are added every 10 minutes, and each block has a number of transactions. All right, this is simple. Okay, and the people who participate in this scheme of block addition and creation are called miners. Okay, this we have already discussed, right? All right. Okay, so now let's look at the process now. The Alice wants to send a Bitcoin to Bob. She creates a transaction. Okay, she sends it to one of the nodes and finally goes to a number of miners. Okay, okay. Now these miners will start building blocks, start creating a block which is still not approved. Okay, all right. And miners, before creating the block, when they create block, they check that all transactions are valid, so no invalid transaction is added. Okay, and miners, why should miner do this work of checking and trying to create a block? Because they will get some Bitcoin for that whole process. Okay, all right. Okay, now each miner will has a set of transactions it has received. Now they will, after some time, when certain number of transactions have reached, they will start working on proof of work, which is a quiz, is a kind of puzzle. Okay, and the miner, the miner, any miner who is able to finish the proof of work first will announce this, that I have created it to the whole community of miners. Okay, so now here comes the concept of proof of work. So we understood it now, that the first miner who is able to complete this first, because all miners are competing in block creation, because there is a money involved with this. Okay, they will, the first miner who wins, who completes it, who completes the proof of work or solves the puzzle, will send it to everyone, and everyone will verify it. And if there is a, in the process of voting process, everyone agrees, then this will be added to everyone's blockchain. Now the question is that what is that puzzle or proof of work? Okay, okay, so idea is to incentivize users, honest users, to participate in the process. And of course, now it is being done on dedicated hardware. So proof of work, let's look at very simple proof of work. Is based on hash, and each hash, doing hash, takes some time. Okay, usually it's a small time. Okay, so there is a prover and there's a verifier. Okay, so a verifier will send a random value of x. The puzzle is that find s such that h or hash of sx starts with n zeros. So output of that, you'll have to find out value of s such that hash of that string that you have to find out, and value of x which is sent by verifier. The output of that, it will be some string of certain size. So it will start with n number of zeros and then some other numbers. Okay, this is a very simple puzzle. All right, but it will take some time, because what is the value of this s? How is there algorithm generate this? No. So it has to be done, and I mean, you'll have to exhaustively find out the value, right? So it will take certain number of time, some time, right? Okay. All right. So which will be significant, right? Okay. Now we can increase, this verifier can increase the hardness of this problem by changing the value of n. All right. Okay. And then this guy, when it finds out s, sends it to verifier and will check it's correct or not. If it's correct, then the whole process goes on, right? So now time taken to find out this s is 2 raised power n times more than just solving this or just finding a hash of any string. Okay. All right, any question? Okay. So now note, not everyone is allowed to add block to blockchain. People who create and propose blocks are, of course, this point we have studied. So proof of work is solution to the hash puzzle. Hash puzzle can only be solved with brute force computation. Okay, so it takes time. All right. Once miner solves a proof of work, it includes all the transactions that it heard after checking that they are correct. So it first verifies all the transactions they are correct and put it in a block, and then transmit that block, send that block to everyone. Okay. So all right. So now let's look at how we'll see how POWs are used. Now hash function that we use is SHA-256. Okay, so this is the first block, and then it's hash. We have seen that when we create hash chain, then we can take hash of this. Okay, and then the miner will look, so basically miner will look at hash of earlier block, look at all the transaction it has received. Okay, and then solve the value of nonce or that value of s. Okay, and create a block. Now finding out the value of s is already done, because after creating blocks he is trying to solve this puzzle. Okay, all right, and then it's announced to everyone. Okay, all right. Now this puzzle is that h of nonce, h of the block, previous block, and the transaction. Hash of all this will start with some number of per n zeros. Okay, and okay, so this value of correct value of s has to be inserted, and this is a puzzle. All right. So now this way, blocks are created. Okay, once this block is sent to everyone, then they will verify it, and then they will do voting, and if they agree, then everything is done. Then the block gets added into blockchain. Okay, all right. So this is of course computationally hard. Sigma miner will take some time to do proof of work. Once miner finds extension, there's new block and proof work, broadcast it to all. And user will always accept the longest chain, which is a valid one. Of course, we will not discuss this point. Okay, so once the block is mined by somebody who has found out proof of work and created this block, will broadcast it to all. Say that I am extending this blockchain, and you please check it works or not. Okay, all right. So this is what it will happen. Okay, so this is something that will be a new block, right? So this block I, basically we are telling there's a block I which will contain the nonce value which miner has created as a part of solving that puzzle or proof of work. Now it will have a hash pointer to the previous block. It will have hash of previous block, this value of hash, and a pointer, okay, which you have studied, and all the transactions. All right. The next block which comes into play will also do the same thing, look at the whole block and then take hash of this and then join, have a nonce or this s and transaction that has a receive in the time and create a new block from there. All right. So process steps are very simple. Okay. L is first broadcast it to all. Okay. This whatever transaction she has created, which will have of course hash pointer and also have other information. All miners listen to all transactions that are happening in that closed network. Miners compete to add new block containing new transactions, because blockchain has to extend every 10 minutes, so all miners will compete because there is some incentive. If once a miner receives a transaction, checks the validity of the transaction, okay, so it means that all, and it tries to create a block, so all the transaction it has listened last few minutes will check the validity of all of these, okay, and then miner simultaneously solve the proof of work, okay, and once able to solve the proof of work, this new block is broadcasted to all miners, okay, and then all the miners that has received that block will check the correctness of all this correctness of all the transaction in the block, and after that they participate in voting, okay. And if the majority agree, the received block is included in the blockchain, and each miner will include this in blockchain, and it's of their interest to include this in a blockchain. Okay, that's all about blockchain. Of course, there's lot of literature available, and you can go to slides here, which will have about 20 slides or so, which you can go through if you want. To summarize, so in this lecture we have looked at the concept of Bitcoin, okay, how Bitcoin works. This is a distributed system, is based on distributed system. It does not work on government, and Satoshi has created this whole beautiful system and believed that the genesis of creating Bitcoin is a computing power. So we have seen while we are discussing proof of work, each miner has to do proof of work. Basically, he has to spend certain millions of some millions of computing cycles to create a Bitcoin, and that itself costs money, right? So there is a, of course, effort required to create a Bitcoin, which is nothing but a computing power, okay. And so Bitcoin creations happens continuously, all right. Bitcoin of course has gained acceptance, is now becoming popular. A good number of organizations have started accepting it. Technology is based on few things. First is identification is based on public key and private key, which is nothing but public key encryption that we have studied, okay. So public keys becomes identity and private key is required to unlock it and for digital signature. Then each user can spend the Bitcoin, and thus it means that that user or Alice has to do the transaction, okay, and transaction is signed by user's private key, so it becomes digital signature. Each transaction also contains a reference, is a hash pointer to the previous transaction, basically previous blocks in the blockchain, all right. And there is a concept of blockchain, which is a public ledger. It means that everyone can see all the transaction happened in the blockchain so far. Okay. Okay. So, and it's based on concept of hash chain. Okay. Linked list where each node contains a hash of previous node. Okay. And then is append only structure. It means that we can keep on appending blocks. We cannot remove the blocks from it. Okay. It's also based on the proof of work. Miners have incentive to solve a puzzle. Okay, in lieu of that they get a Bitcoin, or small part of the Bitcoin. Okay, and once a block is created by user and who solves proof of work, then all the miners approve this, right? And so there is a consensus on new block, that, and then every miner adds that block to a blockchain. So that's all. Any question? Wow, either you understood it fully or you didn't understand at all anything, right? Okay, all right then, thank you.